Siaran langsung ini dibawakan khas kepada anda oleh Akademi Youtuber Malaysia. Tumpukan perhatian anda, siaran langsung akan bermula sebentar lagi. Link sijil akan diberikan di hujung siaran ini. Pastikan diisi dalam tempoh yang ditetapkan. Terima kasih.
Hai, salam sejahtera dan hai semua para guru, ibu bapa dan semua pelajar sekalian. Selamat datang ke Pusat Tuisyen Akademi Youtuber dengan usaha sama e-didik Malaysia dan Kelab Guru Malaysia. Bermula percuma selama ni percuma. Saya perkenalkan diri dahulu, saya Cikgu P, kini mengajar di Oleh Tingkatan 6 Tun Fatimah Melaka. Pada malam ini kita akan bersiaran langsung dari channel Cikgu Hasnitah. Siapa yang belum subscribe channel Cikgu Hasnitah, sila subscribe channel Cikgu untuk tunjukkan tanda sokongan kepada Cikgu Hasnitah. Cikgu Hasnitah kini mengajar di SMK Bangan Jaya Butterworth Pulau Pinang. So hari ini kita akan belajar subjek Fizik Tingkatan 5 dengan tajuk baru dan subtopik 2.1 Pressure in Liquid. So kelas ini akan berlangsung selama 1 jam. Sebelum kita teruskan kelas, suka cikgu ingatkan kepada semua pelajar dan penonton yang ingin menghantar komen, sila gunakan bahasa yang sopan dan gambar profil yang bersesuaian untuk tontonan umum. Cikgu percaya semua yang hadir ke kelas pada hari ini adalah pelajar yang cemerlang dan berdisiplin. So link isi je akan diberi pada hujung siaran nanti. Pastikan anda isi dalam tempoh 30 minit selepas kelas tamat dan anda boleh gunakan sebarang email untuk mengisi link isi je tersebut. So sila fokuskan kepada pelajaran yang akan disampaikan oleh Cikgu Hasnitah. So semoga kelas pada malam ini dimanfaatkan sepenuhnya oleh para pelajar. So saya serahkan kelas kepada Cikgu Hasnitah.
Okey, terima kasih Mr. P, sahabat saya dari Kolej Tingkatan 6 Melaka. Mr. P sihat
Sihat.
Okey, alhamdulillah. Okey, bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Salam sejahtera dan selamat malam kepada semua guru-guru, ibu bapa dan juga khususnya para pelajar yang cikgu kasihi sekalian. Di mana jua anda berada, kami doakan anda sentiasa sihat, walafiat dan sejahtera. Okey, baiklah, sebelum kita mulakan kelas pada malam ini, bagi yang beragama Islam, ayo kita mulakan dengan Ummul Kitab Al-Fatihah dan bacaan doa belajar. Bagi yang bukan Muslim, anda bolehlah bertafakur mengikut kepercayaan masing-masing. Al-Fatihah. Amin, amin ya rabbal alamin. Okey, jadi malam ini anda bersama dengan saya dan Mr. P untuk kelas Fizik Tingkatan 5. Kita sama-sama ulang kaji tajuk 2.1 2.1 Pressure in Liquids. Jadi Mr. P mungkin boleh sharekan slide saya. Okey. Sebelum itu anak-anak jangan lupa link sijil kita akan kongsi di hujung siaran nanti. Okay students, if you are ready and good to go, can you please type in the live chat there, ready teacher, sedia cikgu. Okay, so anda boleh dapatkan slide ini pada pin message, boleh muat turun, boleh cetak keluar dan boleh jawab soalan-soalan yang ada di dalamnya. Okay, apa yang kita kongsikan itu sama dengan slide yang cikgu tunjukkan pada skrin. Semoga membantu anda mengikuti kelas ini dengan lebih baik. Okey, so cikgu tunjukkan dahulu ini adalah jadual kelas kita pada minggu ini telah berlangsung pada Jumaat yang lepas. Kelas untuk tingkatan 4 disampaikan oleh Cikgu Izyan, tajuk dia 2.2 graf gerakan linear. Kalau anda terlepas kelas ni, jangan risau, anda boleh tonton semula pada pautan yang sama di channel Cikgu Izyan ataupun di channel Teacher SlindaNordin. Okey, so malam ini saya akan sambung dengan tingkatan 5. Tajuk dia 2.1 Pressure in Liquid. Saya percaya semua orang dah belajar tajuk ni untuk 5 dan sekarang sebenarnya sedang musim peperiksaan Mr. P di kebanyakan sekolah. Jadi mungkin ini peluang untuk anda mengulang kaji untuk tajuk ini. Tajuk ni tak susah sebenarnya. Okay, students, so without further ado, let us begin with our lesson tonight. Before that, this is our physics panel. Ini guru-guru yang ada di Akademi Youtuber yang telah banyak menerbitkan video dalam BM ataupun BI untuk subjek fizik. Anda boleh dapatkan pada apps Akademi Youtuber ini, boleh muat turun di Android anda. Apa nama apps dia? Akademi Youtuber. Okay, semua video yang dihasilkan ada tersimpan di sini, lebih kurang 25,000 video kesemuanya, merangkumi pelbagai subjek daripada prasekolah hinggalah ke pra-universiti. Jadi video-video ini juga anda boleh jadikan sebagai bahan tambahan mengulang kaji selain daripada buku teks dan buku-buku rujukan yang ada. Okay, so let us begin with our lesson tonight. 2.1 pressure in liquids. In your textbook, it is covered from page 40 until page 48. Alright, okay. Okay, students, so these are the four learning standards in this topic. The first one is to communicate about the concept of pressure in liquid, where you will see there is one formula there we will apply later in calculating pressure in liquid, where P equal to H rho G. And then second is to do experiment to investigate what are those factors affecting pressure in liquids. Okay, and then to solve problem involving pressure in liquids. And last but not least is to communicate about the applications of pressure in liquids in our daily life. Okay, so at the end of this lesson, I hope you will be able to master all the four content standard. Okay, let us begin our understanding in pressure in liquids by looking at this situation. Have you ever heard about limiting factor? Okay, limiting factor, it is a name given to a such deep vehicle. Okay, such deep sea vehicle, DSV. DSV stand for deep sea vehicle. So what is special about this vehicle? This limiting factor. It can carry 2 explorers and can dive to a depth of 11,000 meters below the sea level. Okay, so at this level of depth, we understand down there the pressure is very high, which is more than 1,000 times the pressure at the sea level. You can imagine that how high the pressure down there. And the body of this vehicle has a structure that can withstand this extreme pressure. Okay, and the pressure in the cabin is always controlled so that the cabin can accommodate the explorers in the deep sea water. Okay, so the name of the vehicle is limiting factor. You can Google it from the internet for more information about this DSV, okay, deep sea vehicles. Okay, then students, let us go to our first content standard. Okay, to derive the formula for pressure in liquid, where P equals to H rho G. From these two formula, you learned earlier, okay, in Form 4, the formula for force for pressure, where P is F divide A. Pressure is force per unit area. And then another formula here for density. Okay, you learn this in a lower form also, where density rho equal to mass divide volume. So how we are going to combine these two formula to derive the formula for pressure in liquid, we will discuss in this slide. Okay, so this is the diagram related to this derivation of formula. So you can see there is the liquid column with height H, and the base area, it's labeled there in a container filled with liquid. Okay, then first, how to find the volume of the liquid column, student? Okay, can you tell me what is the formula for volume? Yes, so volume is area multiply height. Okay, area multiply by height or depth. Okay, and then second, we find the mass of the liquid column. Okay, mass of liquid column. This is from the formula of density. So from the formula of density, density is mass per volume. So we make M as a subject, so it turns to rho V. Okay, and then later, student, this V volume can be written in terms of AH. So we have this M equal to rho AH. Okay, then Find the weight of the column W. Remember the formula for weight? Yes, very good. So weight is mass multiply G, okay, gravitational field strength. Okay, and then this one, this mass M can be written in terms of rho A H. So we just substitute into the formula. So it will give us W equal to rho A H G. Okay, for those who have printed out the module, you can work with me to derive this formula. And then second, find the pressure at the base, student. Okay, pressure is force divide area. So in this case, force is represented by weight, which is W, the weight of the column. So W, we can write in terms of this, rho A H G, and then divide with the area A. So this one we can simplify. So finally, we have this formula, P equal to rho GH, where this A can be cancelled off. So we have left P equal to rho GH. Okay. So from here, we have derived formula for pressure in liquid, where P is the pressure, rho is the density of liquid, and G is gravitational acceleration, and H is the depth of liquid. So what about the formula? So the SI unit for pressure is in Pascal. Okay, PA, Pascal. Where 1 Pascal equal to 1 Newton per meter squared, or also equivalent to 1 kilogram per meter per second squared. Okay, so formula for pressure in liquid, P equal rho GH. Okay. Okay, then let us take a look at the second learning standard. Okay, so this chapter is quite short, so I think we are going to go very fast tonight. Okay, so the most important part is the end of this lesson, where we are going to solve a few problems or situation involving pressure in liquids. Okay, now the second learning standard, students, affect pressure in liquids. Okay, so if you look at this situation, okay, actually you can try this at home. You can find a balloon, okay, and fill it with water. Okay, before that, you try to poke a few holes. Okay, you fill up the balloon with water and poke a few holes around it. You will see that there will be water spurts out, okay, from all hole which we poke on the balloon. So if you look here, this plastic bag is filled with water, and then several holes are put in the various part with needle. Okay, and then once you squeeze this part, so actually when we squeeze this part, we are applying force there at that part. So when we apply force to that area, what will be produced, student, from the formula? We apply force to this area, yes, it will produce pressure, and this pressure will be transmitted uniformly, so it will poke out from all the hole. Okay, so what we can observe here, you can see that water spurts out from all direction with the same speed. Okay, so what is the conclusion for this? We understand liquid pressure acts in all direction. Okay, so I hope you are clear with the first example. Okay, now look at the second example. Okay, now we have a plastic water bottle. Okay, we poke 3 holes as shown in this diagram. We poke 3 holes at different depth. Okay, initially we covered those holes with a masking tape. Okay, and then later we fill up this bottle until fully level with water. Okay, anda boleh lihat di sana. Okay, so what happens, student, once we remove the tape from the hole simultaneously? Okay, so you can look at the GIF here. When we pull out the masking tape, the water is spurted out, okay, from all hole, and they spurt out at different distance. Okay, you can see that the bottom hole, the water spurt out at the furthest distance. Okay, at the middle, spurt out at the medium distance, and the hole at the top level spurts out at the shortest distance. So why they are different in the distance of the water spurts out from the hole of 3 different depths? Yeah, very good. That is to do with pressure. Okay, so first when we do the sketching, okay, Okay, so you can sketch according to you can sketch the diagram up here according to the example given in this GIF. Okay, so what relationship we can write between the pressure of water and the distance of its flow from the hole? So you can say when the pressure of water increases, so the distance it flow from the hole also increases. So we understand here when depth increases, pressure of water increases. Okay, I repeat, when depth increases, pressure of water increases. Okay, simple, right? Okay, then student, this is the third example. Okay, look at this third example. Okay, we have a diagram here. It shows a tube which has a different shape. Okay, we have a tube of 4 columns, consists of a different shape. And you can see that when we pour colored water, you can see that all the level of water in each column are, yes, they are at the same level. Okay, if you look this question, compare the height of water level in each column. So how do we compare? You can see obviously the height of water level in each column are the same. Okay, so what conclusion we can make from this third example? Yeah, very good. We can say that even though the shape or the cross-sectional area is different, but it does not give any effect on the water level. So we can say that the cross-sectional area and the shape of the column does not affect pressure in liquid. So we understand when they are at the same level, the pressure acting in each column are the same. Okay, so if we combine these 3 examples, we can come out what are those factors affect pressure in liquid. So the first one is, yeah, you can tell the first one is depth, okay, depth of liquid. And then the second pressure is, yeah, density of liquid. And then the third is G, yeah, gravitational acceleration. Of course, there will be any difference if we find the pressure of liquid on Earth, or find the pressure of liquid on other planets, because they have different G. So these are the 3 factors affect pressure in liquid. Actually, you can get them from the formula itself. All right. Okay, now students, that goes the second contents, second learning standard. Okay, now let us go to the third one, to solve problem coding or involving pressure in liquid. Okay, before that, we have Arif Irhan there. Okay, welcome to the class. Thank you for joining us. Get ready, Arif say. Okay. Okay, then I think Arif is a teacher. Thank you very much, Mr. Arif, for joining me. I think I used to follow your tutorial class somewhere out there. Okay, students. Okay, so look at the first question I show you here. This is the diagram related to the first question. You can see that there is one fish down there at the depth of 1.5 meter from the surface of this water. Okay, this animation show to you. Yes. Actually, it is an animation inside an aquarium. Okay, a very deep aquarium, very gigantic aquarium at the depth of 1.5 meters. So the density of water is given 1050 kilogram per meter cube. So this is the information you are given. We have an aquarium. There is a fish down there at the depth of 1.5 meter from the surface. Okay, that is the first information. Second, the density of water is 1050 kilogram per meter cube. So this is our second information. Okay. And then given the atmospheric pressure is 100 kilo pascal. Remember, kilo is 10 power of 3. Okay, so 100 kilo pascal. And given the gravitational acceleration is 9.81 meter per second squared. Okay, first you are asked to find what is the pressure experienced by the fish caused by the water around it. So first and foremost, you must understand this question. It asking you to find pressure due to water. So we find pressure due to water only. So what is the formula for pressure in liquid? Very good. So it is P equal H rho g. Okay, so we substitute our formula with the depth 1.5 meter, and this is the density of the water given 1050, and g gravitational acceleration of 9.81. So you just press your calculator, the answer will be 15,450.75 Pascal. Okay, or you can also write as 15.45 kilo Pascal, or in scientific notation, okay, it will be 1.545 times 10 power of 4 Pascal. So that are alternative, you can write your answer. Okay, either we write here in this way, or you can convert into kilopascal, or you can use standard notation 1.545 times 10 power of 1234 Pascal. Okay, so I hope you're clear with that. Okay, then in the second question, they ask you to find the actual pressure acting on the fish. Okay, student, what does actual pressure mean? Actual pressure means the total pressure acting on the fish. So if you look at this diagram, how many pressure acting on the fish down there? So you can see there are two arrows there. So the blue arrow refers to the water pressure due to depth. And the green arrow up here, yes, it is due to atmospheric pressure. So there are two pressure acting on the fish. The first one is the water pressure. And then second up here, we have atmospheric pressure. So how to find the actual pressure or the total pressure? Yes, we find the sum of these two pressure. Okay, so atmospheric pressure is given 100 kilopascal in the question. And water pressure, we have calculated from the first part, which is 15.45 kilopascal. So you add these two, so you will find 15.45 kilopascal. Okay, this is already in kilopascal. So plus 100, this is readily in kilopascal. So it will give you 115.45 kilopascal. Okay, as before, either you write in this way or you can use the standard notation. All right. Okay, so this is the actual pressure acting on the fish, 115.45 kilopascal. All right. Okay, then this is the second question. Okay, second question. Now you are given a U-tube as shown in this diagram. Okay, it shows a U-tube filled with two types of liquid. Okay, students, now we are given water, the blue color on the left arm, and then we have olive oil, the yellow color on this side. Okay, so these are the information you are given. First, the density of water is given 1000 kilogram per cubic meter. So find the density of the olive oil. So how to find density of olive oil, students? Okay, so that is our problems. Okay, so this actually from this diagram, you can find some information. Okay, if you look here, the level of this column filled with water is 15 cm. Okay, from the surface to this point is 15 centimeter. While on the right side, the level of the olive oil from the top to this point is 16.5 centimeter. Okay, so how to find density of olive oil? First, you must understand, okay, again, this is the information we are given. Okay, density of olive oil is unknown. So we can write it as rho 2. Rho for density, rho 2. Height of water column from this diagram is given 15 centimeters. So we can label as H1. Okay, and then density of water is given 1000. This one we can represent with rho 1. Okay, and then the height of olive column you can represent with H2, which is 16.5 centimeter. Okay, so what relation we can make between the water and olive oil? Okay, so this is what we can see from this diagram. Okay, at this level, student, or at this point, okay, at this point, actually what happened at this point where the point is level, P1 is equal to P2. What is P1? P1 is the water pressure. Okay, P2 is the olive oil pressure. So at this level, the pressure of water equal to the pressure of olive oil. Okay, so this is the depth 15 centimeter and this is the depth 16.5 centimeter. The pressure at these 2 points are equal. Okay, so this is our first clue. And then what to write next? Okay, we can write P1, pressure of water, in terms of H1, rho 1, G. Okay, while pressure for olive oil, we can write in terms of H2, rho 2, G. Okay, then if you look at these two equations on the left and right, we can cancel off G. Okay, because they have the same value, 9.81. So we can cancel off G. So this is what the equation will become. H1 rho 1 equal to H2 rho 2. Okay, then we just do the substitution. So H1 is given 15 centimeter. Okay, and then the density is 1000. And then this is H2, 16.5 centimeter. And then we have left density of olive oil, rho 2. So we can find them now. Okay, in this case, since both H is in unit of centimeter, so you don't have to convert them into meter. No problem. If you convert into meter, also no problem. But not converting into meter also no, because later we will cancel off both unit. Okay, you will end up with the same answer. Okay, so now for row 2, so we substitute. So this is what we get. Okay, we leave row 2 at this side, which means we bring them to down here. So you press your calculator and solve for this. So you will find the density of the olive oil is 909.091 kilogram per meter cube. Okay, again 909.091 kilogram per meter cube. Okay, so we started from here. If you understand this, I believe there is no problem for you to find density. Okay, sometimes they give us the density, you have to find the depth or the other way around. Okay, so we just use the same method as shown in this question. All right. Okay. Saya pun orang biasa, Arif Irfan. Bukan orang yang luar biasa. Samalah kita. Okay. Kita, saya share, anda tonton, anda share, saya juga sedikit demi sedikit. Students, so example of question, what if we take a short break for now? Nanti kita kembali lagi selepas ini dengan contoh-contoh yang seterusnya. Tapi boleh kita berehat sebentar?
Okay, no problem. Okay, so jangan ke mana-mana. So kita take a break. Okay, so baiklah, jom kita teruskan bersama Cikgu Hasnitah. So silakan Cikgu Hasnitah.
Okey, terima kasih Mr. P. Okey, terima kasih juga kepada yang sedang mengikuti rancangan kita pada malam ini. Selamat datang ke kelas Fizik Tingkatan 5, Physics Form 5 for DLP. Tonight we are discussing on 2.1, pressure in liquids. Okay, students, so actually we have come to our fourth learning standard, the last one. See, I said to you the topic is very short and yet very simple to understand. Okay, so in this fourth learning standard, let us see what are those applications of pressure in liquid in our daily life. Okay, first and foremost, have you ever wondered why the water tank in our house is put on top of the roof? Kenapa tangki rumah letak di atas, tak letak dekat bawah, tak letak dekat lantai? Okay, so what is the reason for that? So it is definitely to do with pressure. So if you look from this slide, a water tank is usually placed in a space between the ceiling and the roof, mean on top of a building. So this is actually to create difference in height between the water level in the tank and the water tap to produce high water pressure at the tap. Okay, and then the water will flow at high speed when the tap is turned on. Itu fungsi dia. Kenapa letak ke atas? So to create a pressure difference. So once we turn on the tap, the water can flow out at high speed. kalau anda perasan bila duduk di apartment, okay, ataupun in a high building, okay, kalau tingkat atas, compare tingkat atas dengan tingkat bawah, ataupun tengok saja rumah kita, when our house is a double story house, okay, you can feel the difference in the water pressure at the second floor and the ground floor. Selalu air dekat bawah tu lagi kuat. Sebab tu berebut nak guna bilik air bawah, Mr. P, anak-anak saya. Semua nak
Oh.
mandi kat bawah. Sebab toilet atas air dia tak kuat. So bila mandi tu dia rasa tak puas. So itu salah satu contoh mudah. A very simple example we can see in our house itself. Okay. Okay, then this is the second example. Okay, the intravenous position of intravenous liquid applied to a patient in a hospital. Ini pun sama juga. You normally see that the IV bag is hang on a top position from the patient. So why? This is also to create a pressure difference. So the liquid in the intravenous can flow and enter the patient's vein from the tube connected to it. Okay, so if you look or if you read from the point given here, a bag of intravenous liquid placed at the position higher than the body of a patient. So actually you can write this point in an essay question. Okay, pernah keluar SPM soalan ni, they ask you to explain how the intravenous liquid works, 4 marks. So you can explain according to this point. Same goes to the water tank just now. All the point given can be used as an answer in essay question. So the pressure due to difference in height of the liquid will push the intravenous liquid into the body of the patient. Okay, and then the rate of flow of the IV liquid into the patient depends on the height of the bag and can be controlled by the adjuster. So you can see the adjuster here. Okay, normally you can see the nurse, it adjusts the adjuster. If it want the liquid to be flow in a higher rate, so it open the adjuster. Or if they want to flow at a slow rate, so they will close a bit the adjuster. All right. Okay, then students, this is the third example, construction of a dam. All right. So in Malaysia, we can find a lot of them because this is the major sources we are using in generating our electricity. Yes, sebab we have abundance of water here in Malaysia and somehow the cost is cheaper compared to any other alternative energy resources for generating electricity. So if you look at the structure of this dam, okay, you can see that the structure is built thicker at the center. Okay, the structure of the wall of the dam is designed to be thicker at the bottom. Why it is thicker at the bottom compared to the top? So yes, this is to relate with the water pressure. As the depth increases, so the pressure down there will be higher. So this is to make sure the wall can withstand high pressure, so it is not easily collapse. Dia tak mudah pecah ataupun runtuh. Okay, so this is the information you can read as well. Alright, okay, then this is the fourth example, fourth application, the use of a siphon. Okay, siphon. For those who are having an aquarium back home, I believe they used to use this technique, the siphon technique, in order to clean the aquarium or to replace the water in the aquarium with a new one. So normally how we do, we use a long tube. You need a long tube and then one pail which is placed at the bottom. So the aquarium must be placed at the higher position. Okay, and the pail must be placed in a lower position. So we can see we are creating pressure difference here. Okay, so a siphon, what is actually a siphon? It is used to transfer water from a higher region to a lower region, and we can use a tube to make a siphon. Okay, so one end of the tube filled with water is placed in the tank, this part at the higher position, and another end is placed at the lower position. Here you can see at D. Right, so the flow of water from ND produces a region of lower pressure at point B. Okay, then the atmospheric pressure will push water into the tube at A. Okay, so this is how it works due to pressure difference. So finally, we can have the water flow out from this N. Okay, due to pressure difference. Okay, students. Okay, now let us take a look of some SPM format paper in order to test our understanding on 2.1. So if you can follow me, I believe there will be no problem for you to answer all these following question. Okay, so let us start with question number 1, students. This is example of question in section A, paper 2, right? Okay, so you can see the question there, 1A. You can see there are two container A, and then we have container B. Okay, this is 2 point at the base, point P, and this is point Q. Okay, what information we are given there? Water pressure at point P and point Q are the same. Okay, they tell you pressure at P, pressure at Q are the same. Okay, and if you look here, the depth of this column, container A, is 12 centimeter, and for B also it has a depth of 12 centimeter. Okay, so first, what is the meaning of pressure, student? Okay, what is the meaning of pressure? Okay, if you notice, I have mentioned pressure at the first part of this lesson. Pressure, so this is general pressure. So what is pressure, student? From the formula, P equal to F divide A. So we can write in words, it is force per unit area. The word unit must be stated, student. Please be aware. If you write force per area, I'm afraid you won't be given any mark. Okay, so it must be written force per unit area. Okay, that is pressure. All right. Okay, and then state one factor affect pressure at point P and point Q. So if you refer to this question, what causes the pressure at P and Q to be the same? If you look carefully, the container has a different shape, right? Okay, they has different shape, and then they have a same kind of liquid. Both are filled with water, mean the density is the same. Okay, then you can see, now they are having same depth. Okay, so we can say the factor affect pressure here is depth of water. Okay, depth of water. Okay, then C, find the water pressure at point P. Okay, how to find water pressure at point P when given the density of water is 1000 kilogram per meter cube. So you just apply the formula for water pressure, P equal to H rho G. So now we just do the substitution. Okay, remember to apply this formula, it must be in standard unit, SI unit. So for depth, 12 centimeter convert into meter, so it is 0.12 meter. All right, and then this is the density 1000 and G 9.81. Okay, so the answer is 1177.2 Pascal. Okay, 1177.2 Pascal. Okay, and then D. Now you are given another situation. Okay, now we have water here. Okay, at the depth of 12 centimeter. Okay, and then another liquid labeled with liquid X. Okay, also with the depth of 12 centimeter. Okay, now, okay, what is the situation? Okay, what is the information we are given? Diagram 2.3 show the water in container B is replaced with liquid X. Okay, so first we have water placed in container B. So we can see the water spurts out from this hole at this distance. Okay, at this distance Z. Okay, and then once we replace this water with another liquid, okay, here we replace this water with another liquid X with the same depth, and it say that liquid X has a higher density than water. Okay, the clue is higher density than water. Okay, so you are asked to sketch the spurt of liquid X in diagram 2.3. So what do you think will happen to the distance of water spurts from this hole when we change or replace the water with a liquid of higher density? So actually this question is a relationship between pressure, and density. So from the formula of P equal to H rho G, so this is density. We understand that when density is higher, pressure is higher. Same goes to the depth. When depth is higher, pressure will be higher. So which means, yes, you must catch a distance which is further than point Z. Okay, so we understand when the density increases, pressure increases, so the water will spurt out at further distance. Okay, are you clear with that? Okay, so I hope you can understand what is the relationship between density and pressure. Okay, density increases, pressure increases. So do with depth. Depth increases, pressure increases. Okay, then what about this, student? The next question, it's about same kind of question, lebih kurang sama. Okay, now we have diagram 1.1. It shows water in a container. Okay, this one. And then the water spurts out from a hole at point A. This is point A due to pressure of liquid. Okay, then diagram 1.2 shows water in a similar container, but the water spurts out from a hole at point B. So now you can see that the position of hole is different. Mean the hole are at a different depth. Okay, so at a different depth, which means our factor here is depth. Okay, so when the depth in difference, we can see the distance of water spurts out from both hole also different. Okay, so first, how to compare depth of water. So this kind of comparison you will find in question 5 and question 6 in section 8. Okay, so we compare. You can write the depth of water at point A is less compared to at point B, or vice versa. You can say the depth of water at point B is greater than that of point A. You can use this mathematical symbol. It is acceptable. All right. Okay. Then compare the horizontal distance X and Y. So this is X. This is Y. You can see obviously the water jet's horizontal distance of X is less. Okay, compared to Y, or vice versa. You can say horizontal distance of Y is greater than X. Okay, and then relate horizontal distance to depth of water. So now what is the relationship? So we can say when depth of water increases, horizontal distance increases. Okay, I repeat, depth of water increases, horizontal distance increases, or vice versa. You can say depth of water decreases, horizontal distance decreases. All right. Okay, then now relate the depth of water to water pressure. So how do we understand water pressure? From the distance it spurts. The further the distance, the higher the pressure. So we can say depth of water increases, water pressure increases. Okay, depth of water increases, water pressure increases. Okay, then state another factor that affects pressure in liquid. So here we understand the pressure is, here we understand the factor study is depth. So other than depth, what are those factors affect pressure in liquid? So you can say density of liquid. Okay, density of liquid. Okay, then. Okay, now students, Mr. Pei, let us try to look at one SPM practice on essay, long essay question, which allocate 10 marks. So if you are given this kind of question, you can find them in section B. Okay, either they will give you a diagram or they will give you a table of choices. Okay, so this will be in section B, question 9 and question 10. Okay, in the exam, you can choose one of them to answer. Either you can answer question 9 or answer question number 10. Or if you have more time, there is no problem, you can answer both. Boleh jawab kedua-dua. Tak ada masalah. Alright? Okay. So what do we have today, students? You can see this diagram. It shows a hydroelectric dam. Okay, so this is a hydroelectric dam. It is built next to a river, and you can see there is a retaining wall there. Okay, and down here where the water flow. right? Okay, and you are given this table. Okay, table 1 show characteristic of 4 dams which is used to rotate the turbine to generate electricity. Okay, so you are given dam J, K, L, and M, 4 choices. Okay, and then you are given 4 characteristic of each dam. The first one is the height of the retaining wall. Second, type of material of the wall. Okay, and then next, the thickness of the wall at the bottom. And last but not least, the shape of the wall. So these 4 characteristics, you are assigned to study the characteristic of the dam that is safe, explain the suitability of characteristic, and determine the most suitable dam. So give reason to your choice. Okay. So for this one, actually there are a few methods you can apply. Okay, as for me, I am practicing this method with my student, tick to pick. Okay, tick to pick method. You tick first and then you pick your best selection. So if you look at this, okay, if you look at this table, look at the first characteristic, height of the retaining wall. So we have 2 choices, low or high. So logically, yes, we must choose a high retaining wall. So you can pick the one with a high retaining wall. So it will be K and L. Okay. Then the second characteristic, student, type of material of the wall. Okay. So you must know the material must be a stronger one, right? A strong material. So we are given 2 choices, wood. I don't think so. Another one is concrete. So which one is stronger? So we choose concrete. Okay, concrete is a better choice compared to a wood. Okay, then the thickness of the wall at the bottom. So as we see in our previous slide, so the thickness at the bottom, should it be small or should it be big? So if you understand, the thickness must be bigger at the bottom. So we tick thickness that is big. Okay, and finally the shape of the wall. Okay, this is the shape of the wall. So we have 2 choices, a few choices there. First, not curved with even surface. Not curve mean plain. Okay. Second, not curved with even surface. Same. Okay, not curved with even surface. And then here we have curve with uneven surface. Curve with uneven. Uneven mean it has a rough surface. Okay. Even mean it had a smooth surface. Okay. Then the fourth one, curve with uneven. So we have 2 choices, either not curve with even or curve with uneven surface. So for this one, we choose a curve shape with uneven surface. Okay, later we explain why we choose this. So if you look, we have tick the characteristic. So now can you see obviously which one is the best choice? Okay, among J, K, L, and M. So obviously L is the better choice as it fulfill all characteristics. So what is our final answer? For this question, you are recommended to put your answer in a form of table. So the first column is the characteristic. Second column is the reason. So for the characteristic, you just write back all the 4 characteristics given. First, the height of the retaining wall. Second, type of material of wall. Okay. And third, the thickness of the wall at the bottom. Write them back. Okay. Then shape of the wall. And finally, your selection. Which one is you choose? You can apply this in your incoming exam. I believe it will help you to collect marks. It also will help your teacher to mark easily. So you can see where is your point. Obviously can see. Okay, now height of the retaining wall. We just write back height. Okay, why? So that to increase the water depth and pressure. So the higher the retaining wall, mean more water we can put in. Mean the depth will be increasing. So the pressure will be increased. The water that come out will be at a high pressure. So it will generate greater energy from the turbine later on. Okay, so it can hold a large volume of water, or you can say increase water depth and pressure. Okay, then what about the type of material of the wall? Okay, just now we choose concrete. Okay, we use concrete material. Why choose concrete instead of wood, students? Yeah, very good. It is to withstand high water pressure. Also, you can also write strong. Okay, concrete is strong and durable. Or you can also say avoid the wall from collapsing quickly or avoid the wall from breaking. Kita elak tembok daripada pecah. Boleh tahan tekanan air yang tinggi. Dia kuat dan tahan. Okay. And then the third characteristic, the thickness of the wall at the bottom. So just now we say big or thick. Okay. From the table, it is big, besar. Why? So again, to withstand high water pressure at the bottom, or to prevent the wall from breaking or from collapsing quickly. There is no problem if your reason is the same. Sometimes, yes, it can be repeated for twice or third. Okay, no problem with that. Okay, then the last characteristic, shape of wall. So we choose curve with uneven surface. Okay, why student choose curve with uneven surface? So this is the reason. If you remember, when you learn optics in chapter 6 back in form 4, okay, a curve shape of a mirror or plane, so produces non-uniform water wave reflection. Means the water will be reflected back to diversity, to a various direction, so it doesn't point on same place. Okay, so this will reduce the water energy once they are reflected from the wall. Second, you can write reduces reflected wave energy, or you can also say to slow down the effect of corrosion. This is for having uneven surface. Okay, when the surface is rough, so it will reduce the effects of corrosion. Okay, if the surface is smooth, it is very easy to be corrode. Dia senang terhakis kalau permukaan dia lembut. Kalau dia kasar, it will slow down the effect of corrosion. So also to prevent cracking on the wall in a shorter time. Okay, so by all these reasons, so we choose L. Okay, just now we choose them L. Okay, then we write back all the characteristics, or this actually will be your combination of answer. So this will be your first mark. Okay, you will get your first mark here, mark number 1. Sorry. Here mark number 1, this is mark number 2, mark number 3 for concrete, mark number 4 for the reason, mark number 5 for big, mark number 6 for this reason, and then the shape, mark number 7, this is mark number 8, mark number 9 when you choose correctly, and mark number 10 for the combination. So this is the format how to collect mark from question number 9 or number 10, which allocate 10 marks. Okay, so you just follow this format. Okay, then students, this is our final discussion for tonight. Let us try to answer formative practice 2.1. Actually, you can find this in your textbook. Okay, formative practice 2.1. Okay, first, state 3 factors affect pressure in liquid. Where to get the 3 factors from? From the formula P equal H rho G. So the first factor is depth, okay, H, and then density rho, and then G, gravitational accelerations. Normally we compare this when we study pressure in different place or different planet. Okay, so if we do it on Earth, mean there are 2 factors, depth and density. Okay, then second, what is the water pressure at this depth? 24 meter in a lake. Okay, find the water pressure. So you can underline water pressure. So just count for the water pressure where the density is 1000 kilogram and gravitational acceleration is 9.81. Okay, so this is the formula for water pressure, H rho G. So just do the substitution. The depth 24, this is in meter. This is the density and gravity. So answer is 235,440 Pascal. Or we can write in standard notation as 2.3544 times 10.5 Pascal. Easy, right? Okay, then the third question, a diver dived to a depth of 35 meter in a sea. Okay, you can underline this information. What is the actual pressure? Okay, underline actual pressure. Remember, actual pressure means total pressure. Water pressure plus atmospheric pressure acting on his body. So density, this is G, atmospheric pressure 100 kilopascal. So first we can find the water pressure. H rho G. So this is the depth, 35 meter. Density 1060 and this is G, 9.81. Okay, so we'll find 363,951 Pascal. Okay, or in kilopascal, we can written as this 364 kilopascal. Okay, if you don't want to write here, no problem. The first answer. Okay, then actual pressure. Student, remember, so actual pressure, we must find the sum of water pressure and atmospheric pressure. So here is in kilopascal, 364 plus 100. So answer is 464 kilopascal. Don't forget the kilo there. Okay, 464 kilopascal. Okay. So, Mr. Pei, I guess that's all to do with my discussion. An example of liquid, as I told you earlier, this topic is a short one, and I think you won't have a problem to understand it. Okay, macam mana boleh faham tak kelas cikgu? Maybe you can give some response to the live chat or anything you would like to ask. We still have a few minutes, okay, to end this lesson. Okay, Mr. P dah share link sijil di bawah. Salah, anda cikgu ke, anda student ke yang suka collect sijil, boleh isi sijil kita yang telah dikongsikan oleh Mr. P lah. Kita akan send Mr. P kepada alamat email yang digunakan. You just fill up with the correct information. Pastikan isi dengan maklumat yang betul. Sometimes dia salah type nama yang second, silap format IC number, then sampai 5 kali dia hantar orang yang sama. Tapi tak apa, kita tengoklah mana, I think yang paling last yang hantar tu itulah maklumat yang sebenar. Okay, so jangan isi kalut-kalut. Isilah dengan berhati-hati. So sijil akan dihantar ke email anda dalam tempoh 3 hari. Okay, dalam tempoh 3 hari selepas tarikh anda isi. Okay, we have Ong Swan Yin there. Okay, thank you very much for joining us, Swan Yin and W. Siapa? Who is that minion? Can you identify yourself? Lin Pei San, yeah, thank you very much for joining us tonight. Okay, siapa lagi yang ada bersama kita, Mr. Pei? Okay, so saya rasa itu saja perkongsian daripada saya pada malam ini. Again, thank you very much student for just don't forget to join us again next week. Next week kita ada kelas akan diteruskan oleh Mr. P. Jadi cikgu ucapkan terima kasih join kelas pada malam ini. So saya serahkan kembali kepada
Okay, so terima kasih kepada Cikgu Hasnitah, selesai lah.
Silakan, boleh teruskan.
Okay. Boleh, okay, selesai lah kelas kita pada malam ini. Tahniah dan terima kasih diucapkan kepada semua yang setia mengikuti kelas dari awal sehingga ke saat ini.
Saya nampak.
So,
boleh ya?
Ada suara cikgu ada stop sikit. Okay, so sila klik like dan share.
Lag sikit kot mungkin line tak berapa clear, sorry.
Ada, sekarang baru tak kira, tapi okay. Okay, so sila like dan share link kepada rakan-rakan media sosial anda. Okay, mudah-mudahan pelajar beroleh kebaikan di atas perkongsian tersebut. So jangan lupa ikutilah kelas fizik seterusnya pada setiap hari Jumaat 9.30 malam untuk tingkatan 4. So next week tingkatan 4 ada kelas cikgu?
Ya, ada bersama teacher Slinda. Kita
Oh
ada
ada,
kelas.
okay. So Ahad
Ya.
adalah seperti hari ini 8.45. Kita akan sambunglah subtopik 2.2. Okay, so rasa kita punya kelas akan stop di sini. So terima kasih kepada semua yang menyokong Akademi Youtuber. Doakan kita terus kuat dan bersemangat untuk membantu dalam membangunkan pendidikan di Malaysia. Sekian, terima kasih. So jumpa lagi pada minggu depan. Okay, ini saja. Bye bye.